What's up guys, in today's video we'll be talking about class in C++. A class in C++ is a fundamental concept while writing object-oriented programming type of code. This will allow to encapsulate the information of the data that is being carried by an object created out of a class. The information that is stored as in the member variables of a class will be accessed only through its member variables or member methods. However, depending on what kind of access specifier of a class that we have used to while creating the member variables and member methods of a class, we can allow other functions which are outside of the class to have the access of those methods and variables. So in this way we can control the accessibility of the different informations that is being held by the object created of a class. So without further ado, we'll start writing the code to see how we can create a class in C++. We'll not write anything very complex. However, the class that we'll be writing here is for the complex number class. So we'll be creating a class that can hold the real and imaginary number of a complex number, and then we'll also have a method to print the complex number. So this will be a class that will be incrementally improving in our future videos. However, in today's video we'll be talking about how to create a basic class, and this is a useful class to have because this is useful in real scenario. So we all deal with complex number, and having to know how to use a class in C++ to wrap around a complex number and deal with complex number, that will help us in understanding how to write C++ class and also how to implement those information on something that we encounter in real life or in many kind of projects. So let's go ahead and start typing our code. So we'll start with including IOStream. So we'll first include the library, then we'll say using namespace std, and then we will have our main function, which is defined as int main, int argc star star argv and this may return 0 since the main function has a return type int. Okay, so we want to have a class of for complex number. So we'll go outside of this main function and type the keyword class. So that is the keyword that we need to use while we'll start creating or defining a class. And we want to give the name of the class as cplx num, and at the end of this class definition we need to use this semicolon. After that we'll use the access specifier. In this case we'll use private, and under private we'll define the class member variables. So for complex number we'll have two different kind of data. One is the real part, which is int real here, and the imaginary part is defined as img. And then we'll use the another access specifier called public, and then we'll define the constructor for this class. A constructor is a function which we need to create an object of a particular class. The name of this function will be same as the class itself, so the name of this function will be cplxnum again. However, since this is a default constructor, so it will not take any kind of input argument. So the input of this function will have no arguments here. And also, if you notice that I have no return type for this function, because constructor of a class will have no return type. So we'll call this as, this is called the default constructor. In order to define the default constructor, we'll call the real and set its value to 0, and we also call imaginary and set its value to 0. So that completes the implementation of the default constructor. Now we'll come back to the main function and we'll create the object. So we'll say creating object using default constructor. So we'll say, in order to create the object of this complex number, we'll use the name of the class, so that is basically the type of this object, and then suppose the name of that object is complex num c num1, and then we'll call this constructor, and we are done creating the object. Next, we'll create, suppose, the method to print a complex number, and the name of that method is, suppose, cplxprint. This will print the real and imaginary part of the complex number. This will help us debugging our code. So it's better to have something like this. So we'll call this and we'll print, suppose, the real part of this class, which is real, and then we'll say img, and we'll say and okay. So once we have this class object defined here, then we have the object name. We now can call this method cplxprint for the object cnum. So the way we do it is we type the name of the object and then use this dot operator, and anything that is defined under public will have, we can have them here after this dot. So we'll call this function here, and that is it. This will print the cnum1. So let's go ahead and build this code. So we'll type g++ -std is equal to c++11 -w-o, then name of the executable is, suppose, class basic, and the name of this code file. Okay, so we have the executable ready, so let's run it, and we see that we have this cnum1 printed here as 0 plus I0, and you can understand why this real and imaginary part is 0 now, because we have called the default constructor, and as soon as the default constructor was created, the real and imaginary part of this member variables were set to 0. And when we printed, this real and imaginary member variables were called again and printed here. The next type of constructor that we'll be seeing here is called, I'll call it a normal constructor. So in this case, the difference with the default constructor is that it now takes input arguments. So in this case, we want to take the real and imaginary part of the complex number object that we'll be creating as input. So the inputs are R and I, and once we have them, we'll set it to the real and imaginary part. So we'll say real is equal to R and imaginary is equal to I. Okay. Next, we'll create another object. Suppose we call it normal constructor, and the name of this new object of the complex num type is suppose name as num2, and this takes two input arguments, suppose 8 and 5. So 8 is the real part of the complex number, and 5 is the imaginary part of the complex number. And after that, we are already there in creating this cnum2 object. And once we have that object, we can definitely call this cplx print method to print it. So let's go ahead and build it again. And yeah, we have this first printout coming from the cnum1, and the second one is coming from cnum2. So far we have learned two things. One is how to create an object of a particular class type using the default constructor and using a normal constructor. Next, we'll learn another kind of constructor. Before that, let's comment it as normal constructor. We now will see another kind of constructor which is called copy constructor, which has the similar kind of structure of the constructor that we have seen so far. However, this is different because it takes a complex object itself as input and copies the information from that object and set those information to the member variables of the current object. So let's see how it is done. In order to create that, as I said, it takes a complex object as input, and the object name is suppose other, and this other object suppose has a method called get real. So this will get the get real method will return the real part. We have to implement that. We have not implemented it yet. And suppose this class method also has another function, member function called get imaginary, which returns the imaginary part of that particular object. So in this case, what is happening is it's taking the other object as input, and it's invoking the method get real to get its real part, and once it has that, it's setting that number to the real part of the current object that we are creating now. And same thing goes while creating the imaginary part. Okay, so that completes creating the copy constructor, and we'll now go ahead and create a new object called cnum3, sorry, I need to change the name here using copy constructor, and this takes suppose cnum2 as input, because copy constructor requires object of the cplx num type as input, and then we'll invoke the cplx print method to see whether the cnum3 has created properly. We have complex number 3 or cnum3 has been defined. Let's build our code and see what we got. So it says that there is no member named getReal, and it also complains about having no member named getImg. So we now need to go ahead and implement them because those are not defined yet. So in order to define them, we need to define a member method inside the class, in our case which is getReal method, which takes no input argument and it returns the real part of the object. Also notice that while calling this copy constructor, we have a const keyword here which ensures that whatever variable that it's taking as input will be unchanged inside this function. However, this function again calls another function called getReal. It also calls the function getImg. So in order to make sure that the other object is not getting changed, we need to make sure that the getReal and getImg methods are also const type. So we have to define the const keyword here as well. Once we have that getReal method implemented, we also need to implement the getImg method, which is similar to getReal, except it now returns the imaginary part of the complex number. Okay, now that we have getReal and getImg method implemented, let's go ahead and compile the code. And we now see that the code compiles properly, and let's now run the executable and see what we got here. So as we can see that the first print statement is coming from here, cnum1, which we have created before using the default constructor. That's why its real and imaginary parts are 0. The second print statement is printing 8 plus i5, which is coming from the method complex print, which we invoked for object cnum2, and after that we used cnum2 to call the copy constructor to create cnum3, and then we called the cplx print method, and we get that it's also printing the same real and imaginary part for cnum3 because it copied the real and imaginary part from the cnum2. Okay, so everything makes sense. So we now have a good understanding how to write a class. However, we are still missing one component here, which is the destructor of a class. So destructor is another function or member function of a class which basically deletes an object whenever that object goes out of scope. In order to create that function, we have a syntax here that we need to use. We first need to type tilde, and then we need to call the function name or the destructor function name, which is again the name of the class, and it takes no input argument here. And just to understand when this was called, I am giving here a print statement calling destructor called, so that we can understand that okay, this is the point where destructor gets called. and then go ahead and run again and see what's we gonna get. Okay, so you see that these are the print statements coming from CNUM1, CNUM2 and CNUM3, and at the end of the program, when those objects went out of scope, the destructor was called and we got these 3 print statements, one for the 3 objects that we have created. Okay, so this is all for this video and I thank you for watching this. Until next time, thank you.